Looking at the definition on page 105, is a single true statement that combines a true conditional and a true converse using if and only if. A biconditional. It's when you've got a true conditional and you've got a true converse, and you combine that hypothesis and conclusion using if and only if. So here's kind of the way it works. If this is your conditional, and I wouldn't necessarily write this down. I would follow along now, because the rest of the day, this is where I've taken the book and I've put it on the dot cam, and I've talked and pointed in the book. I'm looking at problem number 1 on page 105. But I want to do this on here so I've got it in video so I can put it out there if you want to watch it again. Alright. Problem 1 says, what is the converse of the following true conditional? Well, here's the true conditional. If two angles are supplementary, then the sum of the measures of the two angles is, what's it going to be? 180. Good. Alright. That's your conditional. Truth value. What's the truth value of that statement? Jessica. Very good. It's true. For 2 reasons. 1, we know it's true, and 2 is the book just said it was true, didn't it? So now, the converse. Converse means to switch the hypothesis and the conclusion. Anybody want to help me here with the converse? Go. Go ahead.
Me?
Yeah.
Okay, if two angles add up to 180, then they're supplementary.
Let's use the words that are up there. Okay, if
the sum of two angles are 180, then they're supplementary.
Good. If the sum of two angles is 180, then they are supplementary. Agreed? Switch the hypothesis and the conclusion. Truth value. It's true. Very good. So now, what you've got is that a biconditional is a single true statement that combines a true conditional and true converse. We've got a true conditional, right? We've got a true converse. They each have a hypothesis and a conclusion. So what we're going to do is we're going to combine them, and we're going to use the words. What words are we going to use? If and only if. So your biconditional. Anybody want to try to do the biconditional? Say it. Is your arm up, or are you just tearing the blinds up? Keep your arm out of the blinds, please. How about we say two angles are supplementary if and only if their sum is 180. Okay? Make sense? You're taking a true conditional, you're taking a true converse, and you're writing a biconditional, which basically combines a hypothesis and a conclusion with if and only if. Agreed? Okay. Let's try another one. How'd that text box go over there? Alright, let's look at the got it on the bottom of page 105. What is the converse of the following true conditional? If the converse is also true, rewrite the statements as a biconditional. The statement is if two angles have equal measure, so here's the conditional. True or false? True. Good. Converse. Volunteer? Go.
If two angles are congruent, then they have equal measure.
If two angles are congruent, then they have equal measure. Truth value. Good. Alright, so what do you got now? You've got a conditional that's true and a converse that's true. So then what can you write? A biconditional. Any volunteers? Katri?
Two angles are congruent if and only if they have equal measure.
If and only if they have equal measure. Very good. Alright, very good. So any questions on writing a biconditional? Alright, so you were given a conditional that had a hypothesis and a conclusion. You wrote its converse, which switches the hypothesis and the conclusion. If the converse was true, you wrote a biconditional, right? So does that mean a biconditional has a hypothesis and a conclusion?
No.
It does, doesn't it? Okay. So a biconditional has a hypothesis and a conclusion. From a biconditional, can you write a conditional?
Yeah.
Yes, you can. From a biconditional, can you write a converse? Very good. So now we're going to do it backwards. Alright, where you're given the biconditional, and you have to write the conditional and its converse. So now we're going to go biconditional. And I'm on the next page. I'm on page 106. And I'm on problem 2. Array is an angle bisector. If and only if it divides an angle into two congruent angles. Alright? So let's come up with a conditional. Volunteer? Go ahead, Sam.
If it divides an angle into two.
If what divides?
If it divides an angle into two congruent angles.
Very good. If array divides an angle into two congruent angles, then it is an angle bisector. Once we have that, had a biconditional, you wrote a conditional, so what's the next thing you can write? Yes, the converse. Very good. And it should be true as well, shouldn't it? Because it came from a biconditional. So the converse. Anybody? Yes. If what is a angle bisector? If a ray is an angle bisector. Then the ray divides an angle into two congruent angles. Very good. Okay? So that's doing it forward, starting with a conditional statement, determining its truth value. It's true. Write the converse. If it's true, you write the biconditional. If you have the biconditional, you can write the conditional that it came from and the converse that it came from. Clear? Alright, let's say this then. What if you write what if you're given a conditional? Let's say you got a conditional. And your conditional is true. What are you going to do next? Converse. What if you write the converse and it's false? What are you going to do next? Nope, you're just going to write a counterexample. Okay? If you write the conditional and it's true, you're going to write the converse. If the converse is false, you're going to write a counterexample. If the converse is true, what are you going to write? A biconditional. Good. Okay? Then you're going to be given, based on what the directions ask you for, you're going to be given a biconditional. Alright? And what are you going to write? Good. You're going to write the conditional and the converse. What are their truth values? They're both true, aren't they? Why are they both true? Excellent. They have to be, or this wouldn't have been a biconditional. Very good. I think you got it.
What if your conditional is false?
You can't write a conditional that came from a biconditional and it be false. Can't write a biconditional. If your conditional is false, the original statement you start with is false, you're going to write a counterexample. If anything's false, you write a counterexample. Alright? Page 108. Your assignment today is 8 through 18. 8 through 18.